K8BYP not in a ham shack with part 3 of the Trane wreck video series. System would heat okay, but this year cool call terminates in about 10 seconds. Compressor opens up, or compressor shuts off, the outdoor fan shuts off because that low side cutout opens. 24 volts on one side, not on the other. So that's the failure. And what's been traced down to is two things with this high side Schrader access valve assembly. The high side is universally the small line because smaller tubing has a smaller surface area inside and can withstand higher force inside for less pressure. Pressure is force over area. The low side line should be the larger line. Maybe returning vapor, larger line, better flow for vapor, but can't take as much pressure. And that's a universal thing in mechanical engineering. It's called PV. What happened is that when I first started looking at this failure, I took these caps off. As I unscrewed this one, I got a puff of refrigerant out. A week and a half or so later, I took the cap off and there was gross bubbling with oil in here. So I got the Schrader valve core tool and tightened that Schrader valve stem inside. It was loose. I then made the mistake, well, I didn't have much choice, but I put the refrigerant gauge hose on this valve and tightened it down, made a cool call and read 50 psi, which is just a gross failure. When I took the hose coupling off, and these are 1/4 inch flare fittings, there was a geyser of refrigerant that went up and sprayed all over this, clear up here, all the way to the top. So I quickly, I had gotten this extra brass cap because I suspected that was going to happen. I screwed the brass cap on and it did not seal. There's a flare seat up inside this cap that goes against the flare on top of this threaded male portion, male-female set. What that indicates is that the refrigerant and oil was forced out through the threads in the cap, and there's the key of what I want to hammer on here. Firstly, Trane cheaped out and put garbage plastic caps on this. Worse, the caps have a seal surface inside, but see, seals will leak. And that's the original problem. The seal on the Schrader valve stem failed, and the core came loose and leaked through the threads. So to stop that, I put the brass cap on, finger tight. It didn't stop it, so I quickly took it off, put the plastic cap back on, and stopped it temporarily. Then went and got crescent wrenches, took the plastic cap off, put this back on, and tightened it with wrenches. Wrench here, wrench there, and that stopped it. And there's been no more oil leakage. The problem is that will not hold because there could be upwards of 485 psi in that line. And the temperature changes and the vibration and the pressure hammering is going to compromise this seal. And these threads, these are not pipe threads. They will not seal. Even when they're tightened down, there's a gap all the way around that thread, all the way down. They'll just let refrigerant and oil leak right out. So what has to happen is this. For the other ports that aren't leaking, put on proper seal caps. That's from Grainger. It's a nice knurled brass cap with a nice big rubber seal inside. Tighten it down so that little tiny bits of leakage that normally occur won't happen. But see, that's not going to stop it permanently. So after I fix this thing, what I'm going to do is what should be done on all these caps, and that is Loctite the threads with low strength Loctite. It's easy enough to get it apart later, just simple hand tools. But then that seals the threads and guarantees there can't be leaks when the Schrader valve in here fails and when the seal in here fails, because that seal's rubber. It'll take a compression set, it'll crack, it's going to leak anyway. here's what's necessary to fix this and get this system in a position where I can then put a gauge set on it and recharge it without it dumping the refrigerant out that I just put in. Granger JB 1/4 inch gasket seal caps, brass caps with the black Buna seal lip inside. And these giddy gadgets, which are a 1/4 inch female flare, 1/4 inch male flare with a refrigeration Schrader valve inside. And make sure that valve's tight first. And there's apparently a spec on the torque on those. So I'll take the brass cap off this port down here and screw this on. And this has a feature where when this Schrader stem here is pushed down, there's an extension of that stem that goes through and depresses the stem on the old Schrader valve. So when this is screwed on, this portion here is not cut off from the gas. It depresses the old Schrader core while this one remains closed. So that leaves a severe problem. I can't do that. Why? Because if I take that cap off, I'm going to get a face full of refrigerant because the Schrader valve has failed. There is no way under the sun to change that Schrader valve core without dumping, wasting the system pressure, and I don't want to lose about half the charge, or evacuating the system, which I don't have a recovery system, and I'm not going to pay somebody $150 to come out and do it. So that line is at saturation, high side line, R410A, and I measured the pressure when I first put the gauge set on, static conditions, equilibrium at 215 psi. That pressure is what's driving the refrigerant and the oil to blow out that valve. But I got to thinking, the problem I'm chasing is that in cool, that port pressure goes down to 50. And there's the answer. To get this brass cap off with a minimum of refrigerant and oil loss, I need to start the system up, run it in cool till the pressure drops and the cutout opens, and that means that the pressure on that port is 50 instead of 215. Then I can unscrew the cap and then I can put this on. But what we got to do first is we got to take out the blue plug and we got to put Loctite on those threads. There'll be oil in the threads on that port down below. I can't clean it off. If I do, there's going to be leakages that just puts it back on. Loctite will harden if there's oil in the threads. Not ideal, but it'll work. And it's better than nothing because these are not pipe threads. So I'll Loctite this, put it on, let the Loctite harden. Hopefully the thing seals. If it doesn't, then it's just going to dump a system. When it does, if and when it does that, then it's just lost. Then the system will be flat. Then I can just replace all the Schrader valve cores and start over. But I'm trying to avoid doing that. After this seal system work is done, then I'll take these good brass caps off and I'll Loctite them on. So there, in theory, will never be another sealed system leak through these ports. There might still be an extremely small amount through a microscopic pinhole in one of these braze joints. There's bound to be a small amount. But the long-term problem is that those access valves leak grossly. And it sure looks like that's what's caused the failure here, because in cool, both the line pressures are going to 50 and the cutout opens. So the fact that I have proven both a small leak and a gross fountain of refrigeration basically proves that the reason it wouldn't cool is because that valve failed. And it leaked through the seal cap. So shame on Trane or whoever assembled this for not putting a cap I paid $1.50 for, which they could buy for 50 or 80 cents. It's inexcusably sloppy, cheap, and lazy. For a unit, this unit's probably, what, $4,000? Trane couldn't afford an 80-cent cap. It's ridiculous. It's a disgrace. And it almost looks like they want it to fail. And if I can find that, certainly they know about it. They know a whole lot more about HIVAC than I do. Now, the interesting observation with this failure was that I had a gauge on the high side down here. It dumped pressure out. And I started the system after it dumped pressure from that line with the compressor not running. I started the system in heat where it's always started up before, and the compressor immediately shut off. I let the system rest for the compressor timeout period, which is 5 minutes, and the system started and ran marginally well in heat. Interesting observation that suggests that these pressure cutouts can sense low pressure. I don't know that for a fact, but that's what it appears. As to the question of why it would run, I was measuring 150 psi in heat mode on the low side yesterday. That's off the P&T chart in the manual because the outdoor temperature was too high for the chart. Because we don't make heating calls when it's 80 degrees out. So, and we can't charge it under those conditions. But I had to do what I had to do. So it appears to work, okay in heat. It's not great. But what would account for the pressures taking a major dump in cooling? Well, what that appears to be is that this is a switchover valve system. It's a heat pump. The compressor inlet and outlet don't change, but what happens is going between heat and cool, it connects the discharge high pressure liquid line to either the outdoor coil or indoor coil. In heat, it hopefully I get this right. In heat, it connects the high side to the indoor coil through the outdoor coil and back to low pressure, but in cool, and pardon me if I get this backwards, but I think what's happening is that the discharge is going into the outdoor coil, which I seem to verify from the service information from the drawing. But if the system is very low on charge and is trying to dump that liquid into this gigantic outdoor coil, 1, 2, 3, 4, 5, 6, 7, 8, 16 turns all the way around this, then I assume what's happening and why it's dropping out in cool only is that there isn't enough charge in the system to fill this outdoor coil. It's volume. Not enough volume in the system. So when it goes into switchover into cool and tries to dump the output of the compressor into this coil here that is far larger than the one in here. This is not an A coil, it's a single vertical, but that would normally be called the A coil. But it's just losing all the pressure because it's trying to fill this huge volume and it doesn't have enough refrigerant. So that's where it's at. Gate BYP did it.